Hello interwebs, today I want to talk to you about RGB. Now if you've come here for the OpenRGB tutorial, check the chapter markers to skip ahead to the sections that you care about, and yes, this tutorial does include a system where you can just switch off all of the RGB as well. So past that, I love RGB and I could talk about why I love it for like an hour, but this video is going to be about solving the big downside of complex RGB setups, the software. Now, if you buy the same brand of everything, for example Corsair, then theoretically you only need one application to manage it all, and it's not really so bad. But this can be very expensive, and it heavily restricts your part choices to one style or spec. So in real life, people often end up with mixed brand setups that might have 2 or 3 different RGB standards mixed in. If every brand made a nice stripped out RGB utility for their stuff, this might not be the end of the world, as all you really need to do is send commands down a serial bus telling the LED chips in the chain what color to go to. They'll even keep doing that until told otherwise, so if you're doing basic effects like static colors, you don't even need to maintain that control, just set and forget. But every brand wants their own ecosystem to lure you into buying more of their stuff, so the apps for RGB are all massive bloated management packages that do a million things that most users don't care about, or that are already handled by another massive bloated management app somewhere else. This frustration peaks if you have a component that's got a single RGB accent on it somewhere that requires yet another package to be installed just to stop that one logo from doing the rainbow vomit. And I haven't even mentioned the problem with these apps conflicting with one another either. I do have opinions and ideas on how manufacturers could make this whole issue less egregious without compromising their current business models, but that's outside the scope of this video. Today I want to show you how I solved this problem on my shop's demo PC and my home gaming rig using OpenRGB. So let's go. This is the demo rig in my shop, and it's a great example for this problem because it has a very mixed brand setup. We have an EK fan and RGB hub connected to 6 fans and the pump, which is controlled by a 4-pin ARGB wire. There's also 3 additional ARGB fans and an ARGB strip. The Asus motherboard has an accent logo on it, the MSI graphics card has RGB strips on it, and we have G.Skill RGB RAM as well. In terms of software required, this isn't as awful as it looks. Since the ARGB stuff all connects back to the motherboard, most of this can actually be handled by Asus Aura, including the RAM, which will usually be detected by most motherboard RGB software. This leaves us with the graphics card, which will need MSI Dragon Center. So that's 2 apps, which doesn't sound so bad, except that those 2 apps are some of the most egregious offenders of this problem that we're talking about in this video. Asus Aura is part of Armory Crate, a huge package that spawns a dozen background tasks and services, and Dragon Center is equally obnoxious and constantly pushes you to sign into an MSI account. So first things first, uninstall all the existing software and go hard on this, because stuff like Asus Aura digs in real deep and requires a video of its own for total removal. You don't want anything left because it might conflict with a future setup, and also we're trying to get a clean setup without the background bloat here. Next you want to download OpenRGB from openrgb.org. It's a portable app, so you don't need to install anything. I suggest unzipping this into your C drive for simplicity. Run the app and wait for it to load and scan for devices. All going to plan, it should find everything RGB related that's connected to your computer. It will often find other stuff that you wouldn't expect it to as well, like mice and keyboards, even obscure off-brand stuff. You can manually select what you want it to find or ignore in supported devices under the Settings tab. But we'll talk more about that later in my second example setup, where we'll do more advanced stuff. The interface for actually setting the LED colors is kind of clunky, and it doing the thing that you ask it to can sometimes be a bit hit and miss, so don't expect to be able to do amazing sequenced animations here. OpenRGB is best suited for more simple setups, but you can do quite a lot just by having, say, 2 different complementary colors in your case. My advice is to set the static mode and simply dial in the exact color you want as an RGB value on the right. If you want to adjust the brightness, put in lower values on each of the RGB values, or set the color that you like and then use the value field to change the luminescence between 0 and 255. You can also tinker more using direct mode and setting a color value to each zone on each device in order to have, say, a logo and an accent strip be different colors. Or failing that, you can just click Apply All Devices and set one color across everything that OpenRGB has detected. This is great if you just want to do one big solid color, or if you just want to switch off all of the RGB by setting everything to black. Some devices will also have preset effects on them as well. My MSI graphics card here has got a nice chase effect that adds a bit of animation without being obnoxious, so I like to use that. Once you've got things how you want them, click Save Profile As and give it a name. I would suggest keeping this simple for future references. Now you'll want to go to the Settings tab, scroll down and check the Start at Login and Start Minimized options. Then check the Load Profile option and select the profile name that you gave. This will tell OpenRGB to run on startup and load the profile you saved, setting all the colors on startup. And that's it. You now have an RGB setup that's using a single process, a handful of megabytes of RAM, and less CPU overhead than Task Manager can even register. Now we can go further than this. There are a few quirks with the basic setup, including avoiding certain devices that we don't want to control because something else is already managing them, solving a bug with OpenRGB where it doesn't retain settings through a sleep and wake cycle, or even eliminating OpenRGB's background process entirely for an even cleaner configuration. This is my home gaming PC. It has fractal ARGB fans, 2 ARGB lighting strips, an NZXT water cooler with a status screen, Corsair RGB RAM, an Asus motherboard, Asus graphics card, a Logitech mouse, and a Cooler Master keyboard. If I were to do this by the manual, I'd need NZXT cam, Asus Armoury Crate, Corsair iCUE, Logitech G Lighting Link, and Cooler Master's keyboard utility. That is not a fun configuration to have installed and running on every single boot. So let's go through how I minimized the number of large apps I needed for this setup and used OpenRGB to fill in the gaps. To start with, the fans and LED strips are connected to an NZXT Smart Hub, which is a USB controller linking to NZXT cam. The Kraken Z63 water cooler also has a USB connection to cam. We could connect fan power and RGB to the motherboard and leave the Kraken to run its built-in profiles and ditch cam entirely. But because it's managing thermals, fan RGB and the status screen, cam is actually providing a lot of utility to this system. I also think cam is a decent piece of software. It's come a long way in the past 5 years from its clunky origins and has nice lighting effects and fan curve settings. So I'm keeping cam in place. If I had Corsair fans and a Corsair water cooler, I could say the same thing about iCUE. It's okay to have one of these packages running. What we're trying to avoid here is having multiple packages running or single big packages that are doing virtually nothing. So cam takes care of a lot here, but we've still got patches to fill in. So let's look at the RAM next. Corsair RAM can be controlled from OpenRGB, but most Corsair products have a neat party trick called hardware lighting, which is a simple RGB profile that's saved into the device itself. So I can install iCUE, set a hardware profile, and then tell iCUE not to run on startup. I could even uninstall iCUE after that if I want to. But iCUE is fairly clean and it doesn't run a lot of background junk, so I'm going to leave it in place just in case I want to change the colors at a later time. We can't do iCUE's lighting layers with this method, and layers is one of iCUE's other unique party tricks that allows for great sequencing effects, but hardware lighting still gives us a decent selection. So that's the RAM taken care of. Another quick one we can ignore is my keyboard. Although there is a software utility for the Master Keys series of keyboards, and once again OpenRGB can talk to it, It has hardware RGB profiles that are managed with the keyboard shortcuts and saved on device, so we can just ignore this as well. That leaves the mouse, motherboard and graphics card. These are just brand logos, and I really don't want Armoury Crate and G Suite installed just to make those logos match the rest of the system. So now we bust out OpenRGB to fill in the gaps. We're going to install OpenRGB just like before, except this time we're going to go into Settings, Supported Devices, and click Disable All. Now we're going to go through the list and enable only the items that I specifically want to manage. This will stop OpenRGB from conflicting with CAM and IQ, and also has the added advantage of speeding up its hardware scan on startup, since it doesn't need to check for any of the disabled items anymore. Unlike before, we're not going to check the Start at Login option. Instead, we're going to make a scheduled task that starts it. This will do two things. Firstly, a scheduled task will launch OpenRGB, set the lighting profile, and then exit, so OpenRGB won't even be running in the background once its job is done. Secondly, we can add a trigger to the scheduled task to run it again if the computer resumes from sleep, which solves the problem of lighting resetting after a sleep-wake cycle. Now, this might not seem like a problem if you don't use sleep, but I do use sleep for when I leave my PC uploading a video in the evening and I want it to go to sleep after, say, 2 hours, instead of being on all night. And if you're running this on a gaming laptop with RGB accents on it, then this will be super relevant to you. Right-click on Start and then click Computer Management and go to the Task Scheduler library. Right-click and select Create Basic Task. Call it OpenRGB and click Next. Select When I Log On and click Next. Select Start a Program and click Next. Browse for where you saved OpenRGB and select openrgb.exe. In the Arguments field, enter --profile space and then the name of your profile. Now hit Next and then Finish. That's the auto start and exit done. OpenRGB will now run on login, load your profile, and then exit. You won't even see it happening except for your RGB changing colors. Now let's add in the sleep fix. Right-click on your scheduled task and click Properties. Go to Triggers and click New. Select On an Event from the drop-down and click Custom. Then New Event Filter. The way this is going to work is that Windows Power Management writes an event to the system log every time the system wakes from sleep saying the system has woken up. So we're going to add a filter that looks for this specific event. In the event logs, select System, and in Event Sources, select Power Troubleshooter. In the box saying All Event IDs, enter the number 1 and then hit OK, and then OK once more on the Properties window. And we're finished. We've now configured OpenRGB to set the lighting on all miscellaneous devices not covered by the main software package I use without interfering with it, and it will automatically set and exit silently without using any system resources, without installing anything, and without even leaving an icon in the system tray. So there are other methods to managing mixed RGB environments. Signal RGB is also very popular, although when I looked at it, it seemed to burn an unreasonable amount of CPU cycles. But either way, I think this OpenRGB setup is the lightest and slickest of them all, acting as either a complete solution or patching holes in an existing setup. So I hope you guys found that interesting. Thank you as always to my patrons, my channel members, my Twitch subscribers, and I will see you all next time. Bye for now.